going to look more at trigonometric functions, and we're going to we learned how to graph some trig functions in the last lesson, and we talked about domain and range and like just the general how to get a table set up and get your special values and then graph your function. But now we're going to talk about specific characteristic of trig functions. We're going to talk about amplitude and period. The sine waves and the cosine waves, the sine function and the cosine functions, they look like waves. And we actually call these sinusoidal waves. So in general, the sine function is going to be y equals a sine b of x. And the cosine function is going to be y equals a cosine bx, where a, b, and x have to be real numbers. So a and b can be 1, they cannot be 0, and then x is the angle, so x has to be a real number as well. So in general, your sine function and your cosine function is going to be a sine bx or a cosine bx, where a, b, and x are real numbers. The sine and cosine curves can be stretched or squeezed horizontally or vertically. So we call this, when we translated our quadratic functions, we had our parent function, which was y equals x squared, and then we were able to translate it. We were able to squeeze it and make it go wider, or we didn't really squeeze it, we made it become more narrow, and we made it become more wider. So the sinusoidal curves, the sine and cosine curves, they can actually be squeezed horizontally or vertically. And so they are going to have parent functions as well, which is y equals sine or y equals cosine, which we practiced graphing those in the last lesson. So we know how to do y equals sine and y equals cosine. We know what the general graphs look like, and now we can look at how to stretch or squeeze them horizontally or vertically. So amplitude is the maximum distance the graph can get away from the x-axis. So this is how tall the wave can be. This stretches or squeezes the graph vertically. So amplitude is a distance. And so because it's a distance, we are not going to worry about the negative in front of the number. We're only worried about the distance. So if there's a negative number, like it's a negative amplitude, don't worry about it being negative. The negative just flips the graph across the axis. It just reflects it. So amplitude is always going to be positive because it's a distance. If there is a negative with it, it just means that it's going to be flipped over the axis or reflected over the axis. Okay, so what changes the amplitude? So you'll notice that our general form of our trig functions, y equals a sine bx or y equals a cosine bx. So we need to know which one is going to change the amplitude. Is it a or b? So if you look at a few different functions, you'll notice that when you change a changes the height of our wave. And so a is going to be what changes the amplitude. So remember, a is going to happen before the trig function. So it's a times sine x. So whatever that a is, whatever real number that is going to change the amplitude. All right, so if we compare these 4 graphs on your graphing calculator, so if you want to go ahead and do that, look at all 4 of those graphs, you'll notice that as your amplitude increases, as a increases, the amplitude increases. So the bigger a is, the taller or bigger your wave is. So that means that this one right here, y equals 5 sine x, is going to be a lot taller than y equals 1/2 sine x. That's going to be super tiny. And then if I look at these 4 graphs on our graphing calculator, you'll notice that all of these are negative. And because they're negative, they're flipping across the x-axis. All right, so let's do some practice. Which of these 3 have the largest amplitude? Okay, you should have picked number 2, because even though this is a -3, and you're like, well, wait, 2 is bigger than -3. Remember how I said amplitude has nothing to do with positive and negative, because amplitude is just distance, and there's no such thing as negative distance anyway. So this one has an amplitude of 3, and the negative just means that it's being flipped across the x-axis. So for this one, y equals -3 cosine 4x, what would be the amplitude? So go ahead and identify the amplitude. These are your choices. So go ahead and identify what the amplitude would be. All right, you should have chosen option number 1. So remember one more time, amplitude, it appears before your trig function, and it's distance. So we're not worried about if it's positive or negative. So that means that it's going to be 3. Another one, so go ahead and identify what the amplitude would be. So the amplitude for this one should be 1/3, because that's what appears before the sign. All right, so the next thing we want to talk about is the period. The period is the length of the wave's repeating cycle. So you'll notice that the wave repeats itself. And so a period is 1 cycle, so before it repeats itself. So just 1 wave before it repeats. So the period can stretch or squeeze the graph horizontally. So if your period is really small, you're going to have a bunch of waves, versus a large period, you're going to have really big, wide, stretched out waves. All right, so how do you change the length of a cycle? So we know that A affects the amplitude. And then for period, so your period is not the B, which is what we would think, because A was your amplitude. B is not your period. Your period is actually 2 pi divided by B. So think of speed. The faster you go, the less time you take. So the larger B is, the more the graph is squeezed. So that means that the more you can get, okay? So for example, when I have y equals sine x, my B is equal to 1. So that means my period is 2 pi. If I have y equals sine 2x, my B is equal to 2, which means my period is 2 pi over 2, which is just pi. For y equals cosine 1/4 x, my B is 1/4. So to calculate my period, I would have to do 2 pi divided by 1/4. So because this is dividing by a fraction, we will keep change flip. So 2 pi times 4/1, or 2 pi times 4, which is 8 pi. Wow, if your period is 8 pi, that means that one wave fits between 0 and 8 pi. So that's going to be a really stretched out long wave. All right, go ahead and identify the period for this function. Okay, you should have picked pi over 2. So remember, the B value doesn't tell you your period. It just is the B value. Your period is 2 pi divided by B. So 2 pi divided by 4 is actually pi over 2. Okay, let's try this one. You should have picked 4 pi. So your b value is 1/2, which means you should have done 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 2 pi times 2, which is 4 pi. All right, so to graph functions that have different amplitudes, and this is if you don't want to sketch, if you actually want to indicate the amplitudes, what you'll want to do is draw the general graph. So just go ahead and sketch the graph as you normally would, as we have been doing. But then after that, go ahead and stretch the highest and lowest points to the correct amplitude. And so what that means, you're actually going to mark on your coordinate plane the highest point and the lowest point. So it would be a positive number and a negative number. So if your amplitude was 2, then at x equals 2, you should have a mark at x equals 2 where the top of the wave is, and then you should have x equals negative 2 marked where the bottom of the wave is. Make sure the graph still crosses the x-axis at the same places. So to graph sine and cosine functions with different periods, you're going to go ahead and graph the general function like the sketch. Go ahead and sketch the general function. But then after that, find the period by doing 2 pi divided by b. And then go ahead and recalculate your key values, such as pi over 2, pi, 3 pi over 2. If you want to convert those to degrees because it's easier, you can do that. That's 90, 180, 270. And when it says recalculate, that means that if you're generally doing 2 pi, then that means that whatever pi over 2 is, wherever that is landing, you need to divide that by b. And you need to divide pi by b. You need to divide 3 pi over 2 by b, and then those values are where your new graph is going to be. So if you're a little confused on what that looks like, go ahead and look at some of the examples that the book gives you. Those might be a little bit helpful as well, just so you can see what that means by recalculating key values. All right, go ahead and try some of the problems out.